Good day. This is a sample question related to the Precipitate lab, and it's trying to show you how you attack a question that's going to say, hey, we have all these solutions. Which combinations would give us a precipitate? What are the identities of precipitates? And what are the net ionic equations for each precipitate? So we look at this. Here we have 6 solutions, just like you had in the lab, and we have to set them up in a grid. So I go K2S all the way to strontium, so I do them in that order like so. And then I come the other way, lead to nitrate to aluminum iodide, down the left-hand side. So once I've done that, I'm off to the races. That will give me the 15 combinations I need. I don't need to go 6 by 6 because then I'd get, say, K2S and K2S. Well, it's already soluble and you're mixing 2 soluble things that are identical. It will remain soluble. So in this case, I go, hey, I've got K and NO3. Nitrates are always soluble. Lead and sulfide, and I look that up on the chart, and I say, whoa, PBS. If you look up sulfide, lead will make a precipitate with it. Here I have KNO3 again, front end of that, back end of that, so that's soluble. Now I look up strontium sulfide. So sulfide, is it soluble? And it is, so I write down no reaction. This next one I go K and SO4. Well, K is an alkali metal, sodium is an alkali metal, so this will definitely be no reaction. Now I have K and I. Well, K is still an alkali metal, so that's not going to precipitate. And I look up cobalt and sulfide, and I see that that will make a precipitate. K and I, no precipitate. Aluminum sulfide, check it out. It'll make a precipitate. And so I've written the formulas right now because that's going to make it easier for the ionic equations. All right, now I do the same thing. I'm going to come down here. So I have aluminum nitrate, no way. Pb and I, yes. So I know that Pb and I will precipitate out. I look at strontium and iodide, and I say, hey, I don't think that's going to precipitate. This thing likes to jump around a bit. Apologies. So that's no reaction. Sodium iodide, soluble. Aluminum sulfate, soluble or not? Well, it is soluble, so no reaction. Cobalt iodide. Well, if cobalt iodide is soluble here, it's going to be soluble there. Anytime you have a common ion in this game, in this case iodide, there cannot be a reaction. And then we have aluminum and iodide and aluminum iodide, so it's a blank. We don't even care about that. So we just carry on like so. And the thing jumps around on me again. And I say, hey, Pb and I2, aha. So Pb and I2, that definitely is a precipitate. It was a precipitate here as well. Strontium and iodide, nope. And we know cobalt and nitrate can't be a precipitate. Come on. So that's a no reaction. Sodium iodide, no problem. Cobalt sulfate, let's check it out. Sulfate doesn't like to precipitate out that much. So it's no reaction. So there's our 3. We went 5, 4, 3. So now we're only going to have 2 and then our 1, and that'll give us our total of 15. So here we have sodium and nitrate, no way. Pb and SO4, let's check it out, should be a precipitate, and it is. And then we have strontium and sulfate, and sodium and nitrate. Sodium and nitrate can't precipitate, but strontium can. And our last thing is we have strontium nitrate, lead nitrate, and so we have nitrate as common ion, so there's just no way that'll be no reaction. Then you're going to be asked to give the net ionic equation for all these different reactions for different precipitates. And you'll see we have some identical precipitates. So first of all, I look and I go 1, 2, 3, 4, 5, 6, 7. So I have 7 precipitates. Of those 7, I have 2 that are identical. So I have 6 different precipitates that I have to deal with. 1, 2, 3. There's 4, 5, and 6. So I would have 6 net ionic equations. This one's going to be Pb2 plus S2 minus becomes PbS. This is going to be cobalt 2 plus S2 minus becomes COS. So by writing out these formulas of the precipitates, you just backtrack to get your ions, and then just make sure the ions are aqueous. And these things will all have the S for solid as a subscript after the formula. So you will see a test question like this. Hope it makes sense. Watch it again if it doesn't. Make sure you understand your solubility chart.